Wherever you are in the world, welcome to this special presentation that I first delivered at COP28. And in my effort to democratize access to the future, because it was recorded, but the recording wasn't actually released, I've decided to re-record it specially for you. Now, my name is Matthew Griffin. I'm the CEO and founder of the 311 Institute. I'm a futurist. I look up to 50 years out. But actually, my background is in marine biology and oceanography. So I was the only futurist to be invited to COP28 in both the blue zone and the green zone. And this presentation was delivered 3 times. Now, in this particular presentation, what I'm going to be doing is I'm going to be taking you through the challenges that the world has today, the mindset that we need to try to solve some of these challenges, and then the best of all, the solutions themselves. Now, when we actually have a look at this opening slide, there's a little bit of a misnomer going on. Now, firstly, at COP28, we were all really talking about how we save the planet and how we therefore save humanity. But realistically, I argued that we're actually just talking about saving humanity. Now, the reason for that is while there is a lot of planetary damage actually happening, and a lot of that is anthropogenic, the fact of the matter is that whether or not we see runaway climate change that then wipes out the human species, the planet itself will persist. So really, my opening statements were centered around the fact that COP28 itself, the conference of the parties hosted by the United Nations, where we had over 104,000 politicians and policymakers coming together to try to thrash out agreements, is actually more about saving humanity than the planet itself. Now, when we actually have a look at our planet from space, NASA astronauts, in fact any astronaut when they're in space, see something that they call the orbital perspective. Now, when we have a look at this orbital perspective from space, Earth looks fairly straightforward. There are no borders or boundaries, there's no politics, basically there's no war visible basically from 400 miles in space. But actually, as we start zooming in on Earth, as we start coming to ground, things change. When we look at our cities are vibrant, complex places, filled now with up to 8 billion people that inhabit our planet. We have cybercrime and cyber warfare. We have activism. We have terrorism. We have wars. And this is just the starters. When we have a look at waste, there are 2.2 billion tons of waste that we produce, huge amounts of emissions that our factories are producing. We have droughts around the world. We have wildfires, basically in the Arctic and in almost every region of the planet now, which are causing not only huge amounts of damage, but putting more greenhouse gases into the atmosphere. Now, from space, increasingly we're talking about Category 6 hurricanes and extreme weather events that we've never seen before. But on the back of all of this, we have pioneers in transportation and electricity generation. We have pioneers basically in agrotech, so AgTech 2 and AgTech 3. We have younger generations being taught new things in new ways. And then we have technology pioneers developing the latest artificial intelligences and different computing platforms and systems. We have breakthroughs in healthcare. And it's not just this world that we're actually making a difference in. We are actually literally creating new worlds, parallel virtual worlds. So when we actually have a look at the world that we actually inhabit today, yes, there are a huge number of problems, but actually we have a huge number of entrepreneurs and pioneers who are actually doing their utmost to try to solve a lot of these global challenges that we see today. Now, when we really boil it down, when we actually have a look what COP28 is about, what a lot of these activities are about, what are we actually protecting? Now, on the one hand, we think that we're protecting humanity, but realistically, a lot of the activities that are being undertaken today are about protecting us as individuals. So really, at an individual level, we are trying to protect us. Now, we can say that that's a slightly selfish viewpoint, but the fact of the matter is, that's what we're doing. By actually working together, by working to try to solve some of these global challenges, ultimately, we're making the world a better and safer place for each individual one of us and our families. And that's what it's really about, the individual commitment that we each have. Now, When we have a look at the planet, there is only one planet. Yeah? We see a lot of protests saying there is only planet A, there is no planet B. And at the moment, they're right, a lot of the activists. And the reason for that is because when you actually have a look at a lot of the space entrepreneurs like Elon Musk, Jeff Bezos, and so on and so forth, the fact of the matter is Mars isn't online yet. Now, when we actually have a look at Mars, if we really want to go down that rabbit hole of planet B, maybe planet B is for billionaires, we don't know. The fact of the matter is we might get to Mars by about 2035. But terraforming is a century-long process. So the fact of the matter is, we actually only have one planet, really for the foreseeable 100 years. And then we start becoming much more of an interstellar species, which is a conversation for another time. Now, when we have a look at our oceans, when we have a look at some of these big problems that we're actually up against, we've seen a 0.2 degrees Celsius warming of the oceans recently. Now, every second, an atomic bomb's worth of heat is going into the oceans, so much so that last year the oceans were hotter than ever before, and we actually saw more heat zones in the oceans than ever before. However, if we kind of ask why should we care? Now, on the one hand, ocean warming itself is contributing about 1 to 2 millimeters of sea level rise every year, because as the water expands, obviously the oceans rise. And we'll come to water in a little bit. But as the oceans start heating up, their ability to absorb carbon dioxide from the atmosphere is actually improving. Now, oceans actually act as about a sink for about 84% of all atmospheric carbon. So they're a very important carbon sink. So increasingly we see organizations like Blue Carbon basically trying to find new ways basically to suck even more carbon dioxide out of the atmosphere using the planet's oceans. But this is kind of the flip side now. As the oceans suck more carbon dioxide out of the atmosphere, their acidity starts increasing. And that's a problem because right now, up to around 80% of all marine life is being affected by acidity. When we have a look at reef building, for example, coral reef building, between 50 to 70% of coral reefs on the planet now have problems building themselves out. And the reason for this is because as the oceans become more acidic, those acids dissolve the skeletons of fish, the calcified exteriors of echinoderms and sea urchins and so on and so forth. So as we see a warming and increasingly acidic ocean or set of oceans, from a human perspective, bringing it back to that individual level, we will end up destroying some of the fisheries that we actually rely on for our global food supply. Now, when we have a look at water as well, we all know basically that a lot of the world's waterways are far from clean. However, according to the World Health Organization, and these are all official statistics, which you can go and have a look at if you wish, waterborne diseases like diarrhea, for example, actually account for 1.4 million premature deaths every year. And that number is increasing. Now, when we have a look at coastlines, on average, we're seeing about a 4 millimeter rise in sea levels around the world every year. Miami is generally point central for a lot of this for a variety of different reasons. However, when we start looking out to 2050, increased sea levels now start putting around 54 of the world's coastal megacities at risk. Those megacities house around 1.2 billion people. So in the future, we see around 800 million people being more displaced as cities like New Orleans, for example, Shanghai, even London and other areas of the world, Jakarta and so on and so forth, start going beneath the waves, maybe not flooding, maybe not vanishing altogether, maybe not becoming a full-born Atlantis, but nevertheless, we see a huge amount of societal disruption and displacement taking place. Now, on the one hand, this is going to put more pressure on the societies that we live in, because if you have 800 million people leaving the coastlines, where do they go? And immigration is already a very hot topic, whether it's economic migration or increasingly environmental migration from areas, for example, such as the Maldives and a lot of the lower lying islands. Bangladesh is another great example. Now, when we have a look at greenhouse gases, if we start stripping away methane, for example, and nitrous and sulfur oxides, etc., which actually contribute to GHGs, last year, the world emitted 57.4 gigatons of carbon dioxide. Now, that, on the one hand, is a huge amount of CO2 to be releasing into the atmosphere. I think anyone will actually agree there. However, a little bit of good news, basically, is that the rate of increase over the past 3 to 4 years has actually fallen. So last year, we actually saw a 2% increase in global GHG emissions. So while we're still increasing the amount of GHGs that we're actually pushing into the Earth's atmosphere, it's now at one of the slowest rates that we've ever seen. And that's in spite of the global economy growing and so on and so forth. Bearing in mind that a lot of GDP activity and GDP growth is often hooked to industrial complexes, productivity, etc. Now, when we have a look at air, some of us are fortunate enough to live in areas with clean air. But at COP28, they had a special Delhi bubble. And you could actually go into this plastic house, really. It was a sort of plastic tent. And you could breathe in the air of Delhi. And I can tell you that a lot of people actually came out of that tent coughing a lung up. Now, when we have a look at global air quality, on the one hand, pushing so many greenhouse gases and particulates into the Earth's atmosphere, it's bad for climate change, it's bad for global warming, but actually it's also very bad for our health. So last year, again, World Health Organization figures, we saw over 6.7 million premature deaths because of poor air quality. Now, when we have a look at our cities, now I do a lot of business in the Middle East. And when we actually have a look, for example, at Dubai, where COP28 was actually housed, by 2050, we estimate that the average temperatures in Dubai will increase by about 1 to 2%. However, you shouldn't really be paying attention to the top line temperatures. You should be paying attention to the wet bulb temperatures. And actually, when we have a look at wet bulb temperatures that increasingly determine the extent of human survivability in a particular area, we saw areas in Pakistan basically where the temperatures and the humidity reached such levels that from a human perspective, human survivability was zero. Now, when we actually have a look at heat, for example, this year, basically we've actually seen massive heat waves basically across Europe. So a lot of Europe sweltered in 40 to 45 degrees Celsius heat. We've actually seen over 5 million excess deaths from heat. And when you actually have a look at the balance of deaths from cold to heat, we are seeing 8 times more people now dying from excess heat than we used to from cold in terms of a ratio. So our cities are increasingly getting hotter. That creates health and wellness problems. It creates psychological issues for people, let alone the excess deaths that we actually see. Now, when we have a look at food, when we have a look at crops, when we think about sea level rise, now on the one hand, sea level rise means that we end up seeing seawater ingressing into freshwater underground aquifers. Now, on the one hand, that has an impact on the amount of water that we have available to us, fresh water that we have available to us to grow our crops, bearing in mind that crops today account for about 70% of all global fresh water use. And then humans are the other 30%, obviously. However, when we actually have a look basically at our food, extreme weather events over the past 20 years have wiped out, on average, 40 to 60% of crops. Now, when we actually think about a warming, more humid planet as well, we're seeing a significant increase in the amount of pestilence as well. So overall, from a planetary perspective, while we have the technologies right now to increase crop yields, events such as extreme weather and so on and so forth actually mean that we have increasingly less food available to us. Now, this year, basically, we saw in India limited the export of rice because they had very, very heavy monsoons. So again, as we look into the future, we actually see more food scarcity, not less. Now, from a waste perspective, every year we are using 100 billion tons of the Earth's resources. You can think of these as ore, you can think of these as wood, and so on and so forth. We then turn all those resources into a variety of different products and so on and so forth. But every year, we are putting 2.2 billion tons worth of waste, hard waste, to landfill. And if you want to know just how much of that we're recycling, think of a number, halve it again, and maybe, just depending on what that number is, halve it again. Because out of the 2.2 billion tons of hard waste that are going to landfill every year, and by 2050 we expect that to be about 3.4 billion tons, by the way, we are recycling 312 million tons. That's million with an M. So when we talk about circular economy, when we talk about sustainable businesses and so on and so forth, and sustainable living, when do we ever get to the point where, as humans, we are not using 1.7 Earth's worth of resources? Now, when we actually have a look at terra firma, when we have a look at land itself, 75% of the Earth's land surface is now degraded. Now, in the UK, for example, we are seeing land degradation becoming such an issue that the UK government believes that the UK has just 100 harvests left in its soil. In addition to that, we see the sixth extinction event. Now, since the 1900s, we've seen a 20% reduction in the number of species on the planet. Now, that also means that we, for example, if we have a look at pollinators, on the one hand, we believe that the extinction of the bees or certain extinction events that we're actually seeing in the insect kingdom are already costing the world's farming community $577 billion. So when we actually have a look at the sixth extinction event, on the one hand, we have nature coming closer to humans, basically, which means that we have a threefold increase in the number of pandemics, according to different experts and different research that I've seen, and so on and so forth. But actually, it also means that as we see more plants and animals becoming extinct, our coastlines, for example, are actually at even greater risk of being eroded and affected, which then puts humanity itself at greater risk, etc., etc. We are a truly connected ecosystem. And then when we actually have a look at all of these different things, you've really got to ask yourself, is this the actual future that you want for yourself? Is this the future that you want for your family, your friends? Is this the future that you want for the rest of society? I'm hoping you're saying no. But unless platforms like COP manage to come to good agreements that are workable, that are then implemented, the vast majority of all these global challenges that I've just highlighted here only go one way. And it's not the way that you want them to go. Food prices will increase, water prices basically will increase, and water will become scarcer, food will become scarcer. And often when we're talking to children as adults, we say, we're very sorry, we are leaving a planet that is burning and flooding, where you're going to be fighting over food and water. That is contributing to 75% of younger generations being worried about this future. So what do we do about it? Well, let's go and have a think. Now, my first take is this. Stop being human. And I know basically that this sounds completely bizarre, but stop being human. Now, as humans, basically, we do the convenient thing. Let's face it, you don't recycle everything that you can because in the main, it's not convenient. You know, the bin is over there, you can't be bothered to walk to it, or you can't be bothered to sort stuff out, or whatever it happens to be. However, we are also very good at leaving everything to the last minute. Yeah? If I told you that a wolf was coming to your door, from a humanity perspective, we wait until the wolf is in our house, then we lock the door. We need to start thinking about that differently. So stop being human, be more. We need to not just stop emissions, we need to actually take them back out of the Earth's atmosphere. Because even if we stopped emissions today, a lot of the climate challenges that we see today will continue for decades. Now, we also need to be, I think, stop talking about sustainability. We also need to stop being sustainable. Now, again, this sounds really confrontational. However, there's a reason. As Greta Thunberg said, when we have a look at climate change, the fact of the matter is we're burning our own house down. So if we all became perfectly sustainable today, then we are left with a house that isn't getting worse any longer, but it isn't getting better. We end up with a partially burnt down house. And I don't think any of us actually really want that when we see just what our house looks like today. So this is where I argue that we should stop talking about sustainable business, sustainable living, and we should instead talk about regenerative business, regenerative living, where we end up leaving the planet better than when we found it. And with things like ethical capitalism, with things like rewilding and so on and so forth, there are lots of different things that we can actually do. It is possible. So stop being sustainable and be regenerative. We also need to stop reacting. If you actually have a look through newspapers, in 1902, they were talking about the industrial age's impact on the climate. Fast forward to the 1970s, 1980s, and Al Gore, for example, who was vice president in the 1980s, was very vocal about this thing called climate change. How many people did anything? How many governments did anything? How many businesses changed tack? How many consumers radically changed their behaviors? Not many, let's face it. So as humans, basically what we do is we do let that wolf into our house before we think about shutting the door. So we need to stop reacting. We need to be proactive. And as a futurist, part of what I actually help organizations and society do is actually see the things that are coming down the line. We don't really have any excuses for the situation that we actually find ourselves in. And this is why when we actually have a look at COP27, COP28, and so on and so forth, this is why all of a sudden we're pedaling like crazy to try to come to agreements to try to minimize the downsides of the way that we've actually been living basically for centuries now. It's a little bit too late. It should have started really in the 60s and 70s, if we're being honest. But we should certainly have been much more strenuous in the 80s and 90s about some of these conversations. Then we also need to think about this. Stop saying you can't. Now, one of the things that I hear very, very regularly as I travel around the world is people say, well, I'm just one person. Yeah. Nothing that I do is going to matter at a planetary scale. Now, on the one hand, that's sad, because the things that we all do collectively matter. However, you are not some weakling that you might think you are. You are the most powerful version of you that has ever lived. The only things that you increasingly have access to is all of the world's knowledge, all of the world's skills, because as artificial intelligence democratizes access to skills, for example, if you're not a lawyer, you can go and use an artificial intelligence to create contracts. If you aren't a programmer or software developer, you can use artificial intelligence and just natural language to create software. Increasingly, when we have a look at biotech and we have a look at the materials space, you can just type in the kind of materials that you want and the artificial intelligences will simulate those materials for you with particular properties. And then when we actually have a look at our ability to impact the global stage as individuals, if you created a new product today, or if you wanted your voice heard, whatever it happens to be, you have a new idea, that's one thing. But we are all connected to each other. We are connected to 4 billion people on the planet who have internet connectivity, obviously. So you can create something in the morning, have an idea in the morning, and if you know how to execute, and AI can help you there as well, ironically, you could have that idea or that product in front of 4 billion people by the end of the day. And when we talk about product development itself, we're seeing artificial intelligence now developing products in minutes that originally took humans weeks, months, even years. Things like Toyota's new electric vehicle batteries, the third generation, which are a huge leap forward on anything that they've produced before. Those batteries took 3 weeks for an artificial intelligence to produce. Greater energy density, greater performance, and so on and so forth. So you are the most powerful version of you that has ever lived. You have more power than every king or queen that has ever lived, every president or prime minister that has ever lived. And it's literally a finger tap away. So when you think that you don't actually have it in you, or you are insignificant in the grand scheme of things, you aren't. No one is insignificant. But the tools and power that you have access to literally mean that you are a superhuman. Now, when we start looking at solutions, I talked about solutions earlier. When we have a look at the United Nations UN SDG 1, which is zero hunger, we have solutions for the billion people on the planet who go to bed hungry or malnourished, can't say that word, malnourished every day. Now, on the one hand, basically we have what I call AgTech 3. Now, these are things like vertical farms, cellular agriculture. Yes, we have plant-based meats and all those sorts of things. But fundamentally, we are able to put a vertical farm in the middle of the Sahel Desert. We can put a cellular meat lab next to it. And then if you are in the middle of the desert, you can have access year-round to healthy greens, steaks, whatever it is you want. And if we talk about basically those vertical farms, the more carbon dioxide those vertical farms pull in, the 30% higher the yields they produce. They already produce at least 8 crops a year. Unlike traditional farming, the yields that are produced within a vertical farm aren't wiped out because they're indoors. We can grow organic vegetables and so on and so forth indoors because we don't need pesticides, we don't need herbicides. When we have a look at water consumption, we can extract water from the very air in the Sahel at the rate of about 3 litres per minute, depending on the size of the platforms. These are little platforms, but you can scale them up, which then means basically we can actually grow crops with no need for potable water. That's game changing. And then when we talk about energy, well, some solar panels on the roof and there's your energy. So increasingly, we have the ability to create food in new sustainable ways that in some respects have zero impact to the planet. Now you compare that to today's agricultural methods, precision ag, whatever it happens to be, and it doesn't come close. Now, when we have a look at things like UN SDG 12, responsible consumption and production, on the one hand, responsible consumption is down to each and every one of us. However, we have the circular economy. Now, the circular economy, basically, it's a design ethos. This is where we create products where waste is a waste. So, for example, if we create a product that generates waste, then that's a failure of design. And there are a couple of things that we can actually do when we actually have a look at the circular economy. You know, we have companies like Adidas, basically, that are producing circular economy trainers. We have companies like BMW trying to create circular economy vehicles and so on and so forth. But from a recycling perspective, if you as an individual don't take these things to a recycling center, if you don't send them back to the manufacturer or whatever it happens to be, it doesn't matter how circular the products that these manufacturers are creating are. They go into the 2.2 billion tons of landfill. Now, when we actually have a look at things like recycling capacity, so I do a lot of work with the world's recyclers, we just don't have enough. Yeah? On the one hand, there is a huge amount of material that we can actually throw at recyclers, but we don't have the capacity to produce to recycle it. Now, again, this kind of leads us into these sort of multi-dimensional problems. So, for example, when you have a look at the world's investment organizations like UBS, Citi, Legal & General, BlackRock, those kinds of guys, you know, they have typically about $50 trillion worth of assets under management in the ESG space. Now, when we have a look at ESG, a lot of investment organizations invest in E, so environment, but struggle with the S and the G, admittedly. There are very few recycling companies that are actually in any organization's ESG portfolio. So if we really want to revolutionize recycling, bearing in mind that the recycling industry is already a very innovative industry, especially when we have a look at new ways to do chemical recycling, biological recycling, even mechanical processing and recycling. The fact of the matter is, you need capital to be able to build the recycling plants. So why don't we actually see more recycling facilities actually put into ESG investment portfolios? And then when we actually have a look at things like zero everything, the European Union's actually leading the way on this, in my estimation. Now, what we mean by zero everything is at COP28, we typically talk about net zero. That's obviously the big topic of the day. However, in the European Union, they talk about zero waste. So this is where, again, we are trying to send nothing to landfill. They also talk about zero impact because increasingly the European Union want to encourage businesses especially to have zero negative impact, obviously, on the environment. Then we talk about zero harm. Now, in the European Union sort of dialect, zero harm, if we equate it to plastics, for example, is if you're a plastics manufacturer or a company that is using plastics, then the European Union want to encourage you to have a zero harm policy. Now, when we have a look at plastics, an example of harm in the plastics arena is microplastics. So, all companies use plastics. Those plastics enter into the environment in whatever way they do that. They then get broken down, as we see with the giant Pacific Gaia, the trash can of the Pacific. And those microplastics then not only end up in fish or the food chain, they end up in the clouds and they end up in us. So when the European Union talks about the need for zero harm, what they're talking about is they want manufacturers and companies to actually have a look at the life cycle of the products that they're producing and then try to minimize their long tail harm to people and the planet. Now, when we have a look at climate change itself, the big enchilada in the room, UN SDG 13, on the one hand, we've got new clever materials. So we have artificially intelligent created metal organic framework materials that no one will have ever really heard of, but a gram's worth of MOF has more surface area than an entire tennis court. And if you're wondering why that's important, well, if you're trying to create the latest carbon capture technologies, then you need materials with insanely high surface areas that you can then catalyze on top of to then convert carbon dioxide from the air into different substrates, into different materials, stick it underground, use it for concrete, whatever it is that you get up to. And speaking of concrete, increasingly we have carbon negative and carbon neutral concrete, bearing in mind that concrete itself actually generates 8% of all greenhouse gas emissions. So when we actually have a look at clever materials, there is a huge amount of material innovation taking place right under your noses. And that's before we get anywhere near things like batteries and so on and so forth. Now, we're also electrifying every industry. Now, when we have a look at the global car industry, we are electrifying the global car industry. However, when we have a look at heavy industry, which accounts for about 25% of all greenhouse gases, so this is aluminium smelting, steel smelting, concrete production, glass production as well, increasingly we're finding new ways basically to actually electrify those. So for example, when we actually have a look at the steel industry, we're increasingly using electric blast furnaces, which are powered by either renewables and or hydrogen and or ammonia and or nuclear power stations. And again, actually at COP, one of the things that wasn't really discussed much is the agreement on the increase in the amount of nuclear power generation up to 2050, which looks like it needs to triple, and a lot of countries actually signed up to tripling nuclear power generation. But on top of that, maybe most importantly, we've got an energy revolution. Now, when we talk about an energy revolution, one of the biggest problems that we see in the future with countries like India, for example, as India gets hotter, as with any country as it gets hotter, we're all inevitably going to start buying many, many more air conditioning units. So we end up with this cyclical problem where it gets hotter, we buy more aircon units. Those aircon units use electricity from typically fossil fuel sources. That pumps more greenhouse gases into the Earth's atmosphere, and then it gets hotter, and so we need more air conditioning units. You get the picture. Now, when we go back to clever materials, the University of Stanford, as well as a couple of others, have created air conditioning materials that are zero energy. So you can put what is called a nanoscale photonic material onto the roof of your building. They look a little bit like solar panels. And using near infrared and far infrared, they take the heat out of the building using no electricity. And then quite literally, if you're a physicist, you'll know this, quite literally beam that excess heat into the cold depths of space. Because heat will always go from one gradient to another. Now, when we have a look at the energy revolution itself, we've already got solar panels that are 25% energy efficient. We have Perskovite solar panels that are 32% energy efficient. If we put bacteria into a solar panel, then we get a solar panel that is about 48% energy efficient. If we use carbon nanotubes in a solar panel to reclaim the heat, we get a solar panel that is 80% energy efficient. And if we 3D print something called black silicon, you get a solar panel, and we have done this, they are in the labs, that is 132% energy efficient. And for those of you that are geeking out on that, wondering how we actually achieve that, then it's essentially a kind of cannibalistic material. So for every photon that hits that solar panel, it kicks off 0.3 of an electron. So, that's how we get to 132%. Now, when we actually have a look elsewhere, we've got bio batteries, we've got polymer batteries, for example, for electric vehicles that have a 400-mile range that can charge in seconds. We have new kinds of lithium-ion batteries with higher energy densities. For example, if you 3D print a lithium-ion battery, then its anodes and cathodes actually have a much, much higher surface area, which means that we have almost 3 times the energy density in the same form factor. Now, when we actually start having a look at things like nuclear, we've got mini nuclear reactors that are already coming online. We have blue and green hydrogen that's coming online. We've got Wind turbines, increasingly we can 3D print the base of a wind turbine, and we are already creating wind turbines that are 70 stories tall and just gigantic. We're seeing the deployment of floating wind turbines as well. That's it, which means that we are no longer anchored basically to the continental shelf of a particular country. And when we actually have a look at the energy revolution, last year we saw 65 gigawatts of new fossil fuel projects being approved. And that compares to over 254 gigawatts of new renewable capacity. Fossil fuels, like it or not, depending on the country that you're sitting in, are on the decline, certainly as it relates to energy generation, because we are still going to be using fossil fuels to create drugs, plastics, and all sorts of other things. Now, when we actually have a look at clean water, UN SDG 16, we've got some good news there as well. So on the one hand, we have new desalination technologies, and these are actually like a 4-in-1. It's even better. Now, when we actually have a look at, say, Saudi Arabia, when we have a look at California, and when we actually have a look at the UK, desalinating water is typically a very, very energy-intensive process, which is why the cost of desalinated water is 3 times more per litre than potable water. However, if we now create desalinated water using solar panels, as we're starting to see with NEOM, the line basically in Saudi Arabia, that brings the energy cost down. It also means that emissions come down. In addition to that, though, on the one hand, we now have access to cheaper desalinated water because the planet doesn't have a water problem. As humans, we just have the problem of getting access to accessible fresh water on the planet, which only accounts for 0.5% of all of the fresh water that we have on Earth. Now, once we have access to desalinated water at relatively affordable prices, then that obviously helps the agricultural industry. It helps humans as well. So we fight over water less in the future, hopefully, rather than more. However, if you take the brine, the desalinated brine, it contains 5,000 times more lithium than even the richest ores on the planet. So now we have a way to create lithium in a new way, or produce lithium in a new way, bearing in mind that lithium is an increasingly scarce resource. So resource scarcity is a separate issue, but from a lithium perspective, we can get that. We can even get uranium from seawater. So when we actually have a look at desalination, there's a lot going on in that space, and it's generally flying under the radar. Now, when we actually have a look at water extraction, we've already said that as we see sea levels rising, then extraction from ground sources or extraction of water from ground sources like underground aquifers is becoming much more difficult because seawater ingress means that the freshwater aquifers are now increasingly polluted. However, thanks to things like 3D printing and new kinds of heat exchangers and so on and so forth, we can extract thousands of gallons of water from this thing called the atmosphere. And when we have a look at the atmosphere, it contains over 2.4 zeta gallons of water, which is enough for millions of gallons of water for each of us. So when we actually have a look at a future where we might be fighting over water, when you have a look outside of your window, even if you are in the Sahel, the example I used earlier, you can still, irrespective of where you are on the planet, extract water from the air above you. And then, of course, we need the technologies to commercialize, to mature, to be distributed and deployed and all sorts, and that is a capital and that is a business issue, which we won't get into here because there are solutions to that, but it's kind of pure capitalist stuff. Now, and then when we actually have a look at wastewater treatment and what we call zero liquid discharge. So zero liquid discharge relates basically to the processing of toxins within water. These can be heavy metals, they can be things like arsenic, cadmium, for example, if we're having a look at the outflows from mining operations, etc., etc. On the one hand, we can use single-step graphene filters. So you can go to the dirtiest lake, if you like, in Australia, as researchers did, put a straw, this is kind of the life straw if you've ever heard of that, and you can drink straight from the dirty water. However, when we actually have a look at scaling up these single-step water treatment solutions, we are now starting to scale those up as well. So imagine, for example, going to some of the most polluted parts of the Ganges and being able to extract pure, clean water. And that's if you're not extracting water from the air. So when we actually have a look at all of these different things, yes, the world has a staggering number of problems. The world's always going to have a staggering number of problems. They just kind of evolve and change. But as they relate to the environment, as they relate to humanity and society, there are a huge number of solutions out there. We do need a bit of a mindset shift, in my opinion, but that's possible. And ultimately, again, as a futurist, I've been saying this for many years. Traditionally, we've always felt that the legacy that we leave is the legacy that we leave behind. It's the material stuff that we leave behind. It's the assets and wealth that we leave to our families, basically, and to our communities, and so on and so forth. I have always suggested and always promoted that the legacy that we all leave behind is the future that we leave behind for future generations. So I hope you've enjoyed this little presentation. If it's made you think, then excellent. If you have any comments, then just contact me, DM me, and so on and so forth. And if you go to the 311 Institute website, you can download information on all of the technologies that I've discussed, all of the trends that I've discussed. Just go to www.311institute.com/insights, and you can read details on hundreds of emerging technologies that help us solve these problems in new and even science fiction-like ways, and hundreds of megatrends, basically, that ultimately, directly and indirectly, impact everything that we do and every single one of us on this planet. So from me, I wish you a great future, and thank you for watching. Take care. Goodbye.